Hi. We are going to see for why a capacitor is used in a ceiling fan. The most asked question among electrical engineering interview questions about the main function of a capacitor in a ceiling fan. During the class lectures and Viva examination, they mostly asked about the role of capacitor in a ceiling fan. If you are one of them seeking the exact reason for why does a ceiling fan have capacitor, you are at the right forum, and we will answer the question in very simple words to eliminate the confusion about why do ceiling fans have capacitors. Ceiling fan motor circuit diagram. Generally, the ceiling fan motors are split-phase, single-phase AC motors. There are two windings inside the ceiling fan known as starting winding and running winding. Starting winding is also known as auxiliary winding, while running windings is known as main winding. Below is the circuit diagram of split-phase induction motor in a ceiling fan clearly showing a capacitor connected in series with the starting winding auxiliary winding. Before go in details about why a capacitor is connected in series with the auxiliary winding, let us know what will happen if there is no capacitor in a ceiling fan. A ceiling fan without a capacitor. Suppose there is no capacitor connected in the ceiling fan motor circuit. This way both the starting and running windings are connected in parallel across the single-phase AC supply voltage 230 volts. In this case, when current flows through the winding inductors, it will produce pulsating magnetic field from 0 to 180 degrees, instead of rotating magnetic field which is needed for torque and rotation. Due to the single-phase supply, there is only one revolving flux, which rotates in clockwise and then anti-clockwise direction simultaneously. In other words, the direction of motor rotation changes after each of the half-cycle AC sine wave, which leads the rotor to rotate in clockwise and anti-clockwise continuously. According to the double field revolving theory, both torque cancel out each other after a half cycle. The resulting net rotating magnetic field would be 0 starting torque. This is why a ceiling fan, as well as single-phase, induction motors are not self-starting. What is the function of capacitor in a ceiling fan? We know that a ceiling fan cannot be started in single-phase AC supply, but what magic a capacitor do in these motors to make it self-starting? According to double field revolving theory, an alternating flux can be divided into two fluxes which rotates initially in opposite direction. Let's describe the complex scenario in more simple words. A single-phase induction motor can be started by adding an auxiliary winding and a capacitor connected in series to it. Let's know how it works with the help of a capacitor. To start a single-phase AC induction motor, two phases are needed to produce the rotating magnetomotive force, MMF, but we have only one phase due to single-phase AC supply in our homes. Therefore, we need an additional phase to start these kind of motors. We obtain the second phase by adding a capacitor in series with the starting wind of a ceiling fan motor. We also know that current and voltage are in phase, same phase in case of pure resistive circuit. But this is not the case in case of capacitive or inductive circuits. In other words, in case of a pure inductive circuit, current is lagging 90 degrees, behind the voltage or voltage is leading 90 degrees from current, while in case of a pure capacitive circuit, current is leading 90 degrees behind the voltage or voltage is lagging 90 degrees from current. This way, to involve capacitor and inductor, we may product phase shift in a circuit. To do so, we add a capacitor in series with the steering wind. The following happens when we switch on the circuit due to the inductors and capacitors in this circuit. Current leads by 45 degrees from voltage or voltage lags 45 degree behind the current in the starting winding due to inductance. Current lags 45 degrees behind the current or voltage leads by 45 degree from the current in the running winding due to capacitance. Running winding has enough resistance which lead to make the circuit as resistive inductive circuit, and the resultant AC resistance as known as inductive reactance XL. The starting winding has high resistance and low inductive reactance, and the resultant AC resistance equal to the capacitive reactance XC. This way, the resultant current flowing in the circuit is 90 degrees out of phase. It means we got two different, alternating phases which leads to generate a rotating magnetic fields, and the produced torque start rotating the rotor. When the motor achieves 70% plus speed, a centrifugal switch is used to disconnect the power supply to the starting winding auxiliary winding. These type of motors are called capacitor start motors. Due to the high cost and proper maintenance of capacitor start motors, a fixed rated generally 2.5 microfarad to 3.5 microfarad capacitor is used permanently in motor, which is known as capacitor start capacitor run motors. To overcome this problem, as starting winding is small in size, which only helps to produce the phase shift, low torque to start the motor. Therefore, capacitor start motors are not available in large sizes. Keep in mind that if you connect the capacitor in series with the main winding instead of starting wind, the fan blades will rotate in the opposite direction. Now you know the exact reason why there is a capacitor used in a ceiling fan. Thank you.